We are discussing the 2016 free response, which of course is going to be our final exam this Friday. So I'm going to go over every single problem. We're going to go over it in class, and hopefully you study. And when I mean study, that doesn't mean just watch the video or just look over your notes. That means do it again on your own. Everybody, if everybody does that, everybody should get 100%, which is 1/3 of your quarter grade. Number one. So here's the problem where they give you the chart. We're used to this already. Answer the questions. Water is being pumped into a tank at a rate modeled by this. Now remember, these two problems are calculator active, which means you're going to need to use your calculator, and some of you are still not giving 3 decimal place accuracy. Now it's okay if you give more, but we still got like 2 or 3 people only giving 2 decimal places. If you write 2 decimal places like this, 3.71, and that's all you write, we assume that their decimal place is a 0. So if you don't know how many decimal places to write, then you give all. Do not write less than 3, because that would be bad. That's an automatic -1 every time you write down something on your paper. This is measured in liters per hour. Water is being removed from the tank at a rate modeled by R of t, which is given in the chart. And R is differentiable and decreasing. I think that word decreasing is going to come into play there. Selected values of R are shown in the table above. At time t equals 0, there are 50,000 liters of water in the tank. So at the beginning, there's 50,000 liters to start with. Part A, estimate R prime of 2. You know what? I'm going to give you the chart here. So what do we got? 0, 1, 3, 6, 8, 13, 40, 11, 90, 950, 740, 700. Estimate R prime of 2. In other words, estimate the slope when t is 2. Now, is t on this chart? No. So if the number is not on the chart, you have to use the 2 numbers that immediately surround it. So 2 is in between 1 and 3. You have to use these 2 points to compute the slope. So all you have to do is this. Y minus y over x minus x. Full credit, baby. Some of you feel the need to punch this in on your calculator. No, just leave that, and that is full credit. Do not even touch that. And please go y minus y over x minus x, because I remember when I'm correcting it, there are again 2 or 3 people putting x minus x over y minus y. You just lost that one easy point there. Indicate units of measure. Some people are not indicating units of measure. That's an automatic point deduction if you don't do that. Now, what are the units? Well, R is measured in what? How is R measured? Liters per hour. Or liters per hour. So what happens when you, so this is measured in liters per hour. This is measured in hours. So liters per hour, per hour. So liters per hour, and if you want to, you can see liters per hour squared. It's quite simple. You just, the derivative is a slope, right? And how is slope measured? Rise over run. So you just got to look at the units of this and divide it by the units of that. Part B, use the left Riemann sum with the 4 subintervals indicated to estimate the total amount of water removed. Well, if this is the rate at which water is being removed, how do you figure out how much was removed? You do an integral, right? So an integral from 0 to 8 of this function will tell you how much was removed. But since it's given in a chart form, we cannot compute it exactly, so we can do a left Riemann sum, a right, a mid-one. This one we can't do a midpoint, because between 0 and 1, we don't know what the value is at 1/2. We can do a trapezoidal one, but they want us to do a left Riemann sum. So we know how to do that. From 0 to 1 is 1. And then I'm going to use the left one, right? Let me just make sure it's left. Yep, left. So 1340 plus, from 1 to 3, it's 2. And then you use the left one. From 3 to 6 is 3. And then you use the left one for the height. And then finally, from 6 to 8 is 2, and then you use the left one, 740, and just leave it. Do not punch this in on your calculator or try to simplify it. Just leave it. That's full credit right there. Because if you do any one thing wrong, you're just going to lose the 1 point you just got there. Now, is this an overestimate or an underestimate? And give a reason. Okay, so this is 2 points right here. Now, it says R is, I forgot already, R is decreasing. So if you forget what to do, draw the picture. If you have a function that's decreasing, and you use the left endpoint to cap off the rectangle like that, then look, is the area of that rectangle above or below the actual area? It's above, so it's an overestimate. Why? Because R is decreasing. That's what they want. Do not write anything else. So you got 1 point, 2 point, 3 point, bam, easy. C, use your answer from part B to find an estimate of the total amount of water in the tank to the nearest liter at the end of 8 hours. Now, some of you didn't read that, to the nearest liter. They want you to round off to a whole number here. So that's the only time you don't give at least 3 decimal places, when they actually tell you to round it off to the nearest whole number. So first of all, how much water is in the tank? Well, we started with 50,000, right? Plus, how much was taken out? Well, water is being removed at this rate, and so we approximate how much water came out right here. So whatever answer you got there, now some of you actually computed it, I don't know what the number was, but you can, or if you didn't compute it, just put that thing here. So that would be 1 times 1340 plus 2 times 1190 plus 3 times 950 plus 2 times 740. And then, and water is being pumped into the tank at this rate. So how do you figure out how much water, if this is the rate at which water is being pumped in, how do you figure out how much was actually pumped in? You do an integral from 0 to 8, right? 0 to 8, yep, of whatever this function is. Now, since this is already defined on the paper, you can just put W of t there. You don't have to rewrite it again. And then, of course, you will compute this on your calculator. Now, you cannot just leave that integral there. You actually have to compute it. So you punch it on your calculator, you give 3 decimal places, I don't know what it is, and then you can just leave it like that. You don't have to add these 3 together. Well, actually, though, it says to the nearest liter, so maybe they do want you to punch everything in and then round it off to the nearest whole number. Maybe we better do that to be safe then. And then finally, D. In fact, I'm going to expect you to do that on Friday's test. Now, part D is very difficult. Okay, it's very difficult, so that's why you need to get the basic ones over here. Is there a time t when the rate at which the water is pumped into the tank the same as the rate at which water is being removed from the tank? Explain why or why not. From 0 to 8. So we want to know the rate of the water being pumped in, which is this. Is that going to ever equal to the rate of the water being pumped out? So first you write that on your paper. Is there a time when this rate is equal to that rate? Well, yeah, when this minus this, remember the net rate is equal to 0? Now, somewhere between 0 and 8 now, some of you could put it together, some of you couldn't. So what you do is, this is what you do, you plug in 0. If I plug in 0, in fact, you want to call this n for net rate then, if you rather. Okay, well, how do you compute n of 0? You plug in 0, so you get W of 0 minus R of 0. You don't have to call it n, you could have just done that. Now, you need to do this on your calculator, okay? So, you take the 0, plug it into here, and subtract 0 when you plug it into there, which is 1340, and I don't know, you get some number. And then what about at 8? If you compute the net rate at 8, that will be W of 8 minus R of 8. Punch this in on your calculator. R of 8 is on the chart, so whatever you get minus 700, you get another number. Now my guess is I don't have anything written here, but one of them is going to be positive and one of them is going to be negative. And since this function is continuous, what? The intermediate value theorem guarantees it, right? Because if this, I don't know which one is positive and which one is negative. If this is positive and that's negative, it has to hit 0 somewhere in between there, Or if this was negative and that's positive, it's going to hit 0 somewhere in between there because this is a continuous function and the intermediate value theorem guarantees it. Yeah, that one's tough. So, like I said, if you want to stay in the game to get your 5, you got to answer the other ones. You cannot make mistakes on those. Number 2. Particle moving on the number line. You know this is going to be on there too. So a particle is moving along the x-axis, and here is the velocity. And again, this is the last of the calculator problems. The position at x equal 2 is x equal 2 when t is equal to 4. That's the same thing as saying x of 4 is equal to 2. A. When time is 4, is the particle speeding up or slowing down? Now some of you are still making number lines, and that's fine. You can make number lines, that works. But since they're only asking at a particular value, I think it's easier to compute the velocity and the acceleration at 4 instead of making number lines. So first, how do you compute the velocity at 4? You plug in 4 here on your calculator. So 1 plus 2 sine of, what is that, 16 over 2, which is 8. Punch that in on your calculator and you get a number. I don't know what that number is because you're going to do this. I'm not going to do this. Okay, now they're asking if the speed is speeding up. Is the particle speeding up or slowing down? That's the same thing as asking, is the speed increasing or decreasing? And how do you determine that? You have to look at the velocity and the acceleration. So you need to compute the acceleration, which is, of course, the derivative of 1 is 0, and 2 times the derivative of sine box is cosine box times the derivative of box, which is t, correct? 2t over 2 is t. So how do you find the acceleration at 4? That would be 2 times 4, which is 8, cosine of 16 over 2, 8. Punch that in on your calculator. Now, if they both come out to the same sign, then the particle is speeding up, right? If they have opposite signs, the particle is slowing down. So I'm not sure what it came out to, but you're going to have to do that on your calculator. And I also want to note that also you don't even have to compute the derivative. You can have your calculator do it, right? So you can do this. Tell your calculator in run matrix mode, compute the derivative of 1 plus 2, and make sure your calculator is in radian mode here. When x equals, oh yeah, you have to punch it in as x, yeah? And x equals 4. So you could just tell your calculator, compute the derivative of this and plug in 4. So that you don't even have to compute the derivative if you're scared of making a mistake. And again, so to answer this question, if one of them if they're both the same sign, either plus plus or minus minus, then the particle is speeding up, right? And if they're opposite in sign, like if this one's plus, this one's minus, or this one's minus, this one's plus, then the particle is slowing down. Part B. Find all times t between 0 and 3 when the particle changes direction. Now, when does a particle change direction? When the velocity changes sign, because the velocity tells you whether you're moving to the right or to the left, right? So what you need to do now is make a number line for the velocity. Here's your velocity. Graph it on your calculator between 0 and 3. And I'm not sure what I'm not sure which way it's gonna cross. It might look something like that. That's my guess anyway. I don't know what it looks like. You have to do this. And then you got to compute where it crosses the x-axis there. Let's call it A. So you guys know how to calculate that point. So if it does indeed cross, that's where it changes direction. Because if the velocity is positive, if it's above the x-axis, the particle is moving to the right. And if it's below, then the particle is moving to the left. So if it crosses the x-axis, that's where it changes direction. So the answer would be whatever that number is, and make sure you give 3 decimal places. And what's your answer? Because the velocity changes sign. That's the reason. Part C. Find the position of the particle. Now some of you, when I corrected this, come on. We know how to do this. This is code red. Now this is the first time we're using code red. You're going to find that you're going to use it like 4 or 5 more times on this test here. So again, if they give you a function, in this case velocity, and you have to find out something about its antiderivative, which is position, that's when you do code red. So I'm going to integrate the velocity, and I can just put v of t because it's already defined on my paper. And what limits am I going to put here? They want to know that at time equals 0, and they already told me at time equal 4, so it's going to be from 0 to 4. That's equal to, the antiderivative of velocity is x, position. Plug in the top number, plug in the bottom number, subtract. This is code red, the fundamental theorem of calculus part 2. Now, this one, they told you, this is equal to what? 2. This can be computed on your calculator, right? And please give at least 3 decimal places. So how do you compute x of 0? Well, if you bring this one on this side, x of 0 is equal to 2 minus whatever integral you got there. And you could leave it like that, or you could actually do the subtraction on your calculator. But please give at least 3 decimal places there. And then D, this is probably the easiest of all the problems. Find the total distance traveled from 0 to 3. Now make sure you do 0 to 3, because I remember correcting it, some people are not doing 0 to 3. So how do you find the total distance traveled? It's the integral from 0 to 3 of the absolute value of the velocity dt. If you don't put the absolute value on, you just lost 2 points right there. If you don't put the absolute value on, what you're computing is the displacement. They want total distance traveled, so you need that absolute value there. 1 point for this integral, and 1 point for the correct answer. If you don't put any absolute value, that's minus 2 already. All right, now for the non-calculator part. Here we go. This looks like a whole bunch of code reds we're going to be doing here. Now, some of you were befuddled on this. How many times have we done this problem? Many. You know this problem is going to be on there. 2, 4, 6, 8, 10, 12. And this is -4, and then it goes up to 4. Every year it's the same thing. They just give you a different graph, or sometimes they give you a chart. Okay, this is 4 and -4, and then it goes down through here. So wait, this is 2, 4, 6, 8, 10, 12. So here's the point 12, -4. They give you some key points, and -4, -4. Now, I remember a lot of you lost a boatload of points because you didn't consider the endpoints. So you have to read the problem. G of x is equal to the integral from 2 to x of f of t dt. Now, whenever you see something like that, I think I'm going to be using the fundamental theorem of calculus part 1 somewhere in this problem. That's what's going to happen. Wait, let me check on something. All right, so part A. Does G have a relative min, max, or neither at x equal 10? So how do you find maxes and mins? You take the derivative and you make a number line. So we need to compute the derivative of G. Now, if G of x is defined as this integral, how do you compute the derivative? You use the fundamental theorem of calculus part 1. You take the x and plug it in there, which is f of x, and then you multiply it by the derivative of that, which is 1. That's it. That's how you take the derivative of a function that's an integral. Okay? So g prime of x is equal to f of x. So if I'm going to make a number line for g prime, that means I'm making a number line for f, which is this graph over here. So all you have to do is make a number line for this graph. Where does it touch the x-axis? -2, 2, 2, 4, 6, 10. Then you look, is it above or below? Below, above, above, below, below. What does this mean? G is decreasing, G is increasing, G is increasing, G is decreasing, G is decreasing. So now the question is, does G have a max, min, or neither at x equal 10? Right, here's x equal 10. If the graph goes downhill and then downhill some more, does it have a max or a min? Neither. So the answer is neither. And what's your justification? G prime doesn't change sign. This is right, does not change signs. Okay, what if they were to ask you, is there a max or a min at x equal -2? Well, that would be a minimum there. Why? Because G prime changed from negative to positive. That's all on the 3rd page of the cheat sheet, people. What about at 6? Max, min, or neither? Well, there's a maximum there. Why? Because G prime changed from positive to negative. What about at 2? Neither, because G prime did not change signs. That's how you justify your answer. B, does the graph of G have a point of inflection at x equal 4? Justify your answer. So we need to make a number line for the second derivative, because that's how we find points of inflection. Now, the second derivative of G is equal to, well, if G prime is F, then wouldn't G double prime be F prime? You need to write this on your paper, you know. Because right there, this thing was worth 1 point, just for writing it on your paper. So if I'm going to make a number line for G double prime, I'm making a number line for F prime, which is the slope of this graph. So the first thing you look for is, where is the slope 0? Nowhere. Next, where does the slope not exist? When you have sharp points. Well, I see a lot of sharp points. Yeah, and yeah, that's it. So, where does the derivative not exist? At 0. Right there at 2. Right there at 4, because we got sharp points. Right there, where's that? 8. And then 10 got another sharp point over there. So what do you put on your number lines? What are critical points? When the derivative is either 0 or doesn't exist. That's what goes on the number line. And then, how do I fill in the signs? Well, if the graph is going uphill, the slope is positive. Downhill, negative. Uphill, positive. Downhill, negative. Oh, missed one. Uphill, positive. Downhill, negative. So the question is asking, does it have a point of inflection at x equal 4? And the answer is yes, because, oh, I forgot to write this. G is concave up, G is concave down, G is concave up, G is concave down, G is concave up, G is concave down. So is there a point of inflection at x equal 4? The answer is yes, there is a point of inflection. Why? Because G double prime changes sign. That's all you gotta say. Some of you don't even have these number lines on there. I mean, what were we doing the whole year? Making number lines, right? Anytime they ask you for max, min, point of inflection, increasing, decreasing, concave up, concave down, there should be number lines. And some of you are still not labeling them in the correct way. It's madness. Find the absolute minimum. Now, a lot of you got a whole bunch of points taken off here, like I said, because you didn't consider the endpoints. Now, it says absolute minimum and maximum on this interval. Look right here. On this interval. See how it includes negative 4 and 12? Okay, so we need to go back to this number line. So which one you want to do first? Let's do minimums. Well, where do minimums occur? Right here, right? Because look, at negative 2, but there's another one at that endpoint right there. So your minimum points are going to be at negative 2, and what's the endpoint? 12. If you do not consider the endpoints, you lose half the points right there. Because that's what they want you to do. When they ask you to find absolute minimum, they want you to get all the minimum points and compare them and pick the smaller of the two. Now, how do I compute these two numbers? Like a lot of you, now it says the minimum value. That means the y coordinate. Some of you just only gave the x coordinate, that's why you lost points. So how do you do that? Code red. Exactly. Well, no, it's not code red. No, yeah, this is not code red. What am I talking about? This is not code red. I thought we were going to use code red, but we didn't. So here's g of x. How do you compute g of negative 2? You simply plug in negative 2 there. So you get the integral from 2 to negative 2 of f of t dt. But since the smaller number is on the top, we reverse the limits. But of course, that negates the value of the integral. And the integral from negative 2 to 2 is the area, since this is the graph of f. So here's negative 2 to 2. We need to compute that area right there. But that's just a triangle. 1/2 base times height. That's 8. So the answer is negative 8. Now what about 12? Then you're going to plug in 12. So the integral from 2 to 12 of f of t dt. Okay, so from 2 to 12, we need to compute these areas. So, so that's again 1/2 base times height, 2, 4, 6, 8, 10. So this is also 8. Why don't we just put the areas in? This would be 8, and this would be 4 then, right? So what would be the integral from 2 to 12 right there? This one cancels out that one, because remember, if it's below the x-axis, it counts negative. That also counts negative, so the answer is -4. So which one is smaller, -8 or -4? So the absolute minimum is g of -2 equals -8. Actually, they really only want the y-coordinate, which is -8, but if you wrote that, that would be fine. But you cannot just give the x-coordinate, you have to give the y-coordinate. Now, what about the absolute maximum value? Well, there's a maximum here at 6, but then at this endpoint, there's also a maximum, and that's at -2. So, we have to compute, what is that? -4 and 6. See, what they want to see is you actually comparing all the maximum values. And again, how do you compute g of -4? You gotta plug in -4. So the integral from 2 to -4 of f of t dt. But then again, the small number on the top, so switch the limits, which means negate the value, f of t dt. So, what is the integral from -4 to 2? Well, let's just put, so from -4 to 2, what is that? Well, this cancels that, right? And so all that's left is this, which is 4. So that comes out to -4. And then what is g of 6? G of 6, if I plug in 6, you get the integral from 2 to 6 of f of t dt. Okay, the smaller numbers on the bottom, so that's easy. So what's that? That's 8, right? What's bigger, -4 or 8? I think 8 is. So the absolute max is at g of 6, which is 8. So again, you have to consider the endpoints or you lose half the points right there. And then part D, between -4 and 12, find all intervals where g of x is less than or equal to 0. This is part D. In other words, where is g going to be negative? Well, we can actually use the numbers we got here. Okay, well, first of all, why don't we figure out when g is equal to 0? Now, where would that be? Well, obviously at 2, right? Because if you plug in 2 here, the integral from 2 to 2 is going to be 0, right? That's one of the properties of integral. So we're looking for when it's going to be negative. Well, what about -2? We already computed -2, yeah? What did it come out to? -8. G of so we want negative, so from -4, what about, oh, we already computed -4. See, look, you can actually use these. -4, -8, what about at 0? Well, duh, because this is negative and that's not going to offset it, right? Because if you add the 4 to that, so it's still going to be negative up until 2. So -4 to 2. And notice that it's or equal to, yeah? And then some of you are not using the proper symbol there. And again, if you don't know, put a comma. Do not write the word and. That would be very bad. Because that means intersection, which means no solution. Put a comma if you don't know. Now what happens right here? So we know at 2 it's 0, and then you're going to add this area there, and then you're going to subtract that. So these cancel out. And then once you get to 10, then since it's below the x-axis, it's going to count negative. So from 10 to 12. I mean, if you can't do it by looking at the graph, then look, you already got some key points there. Why not compute the value of g at all of these different points then? And then you can kind of put that together there. All right, number 3. So that was an intense problem right there. And number 4, the differential equation with the slope field. This problem is definitely on there. You know, the test does not change that much from year to year, you know, people. That's why I just want you to study something. Just study it intensely. This is it right here. If you can study this and understand every single problem on here, I don't see why you can't get a 5. But then some of us are having problems with multiple choice because look what happened on the final exam, right? You need the nuts and bolts as well. Okay, part A, on the axes provided, do the slope field. Now mostly everybody got this. Now this is only worth 2 points. Please only give the slope, draw the slopes at the indicated points now. Some of you are giving more than what's necessary. There's only 6 points here. So this is 0, 0. If you need to, write down the coordinates that actually do it. 2, 1. What is this? 0, 1, 0, 2, and 2, 2. So what happens if I plug in 0 for x and 0 for y? You get 0, so gunk, horizontal line. What if I plug in 2 for x and 0 for y? You get 0 over 1, which is 0. Bam! What if I plug in 0 for x and 1 for y? You get 1 over negative 1, which is negative 1. 45-degree angle. What if I plug in 2 for x and 1 for y? What do you get? 1 over 1 is 1. Boom. What if I plug in 0 for x and 2 for y? What do you get? 4 over negative 1. So negative 4, just make sure it's steeper than negative 1, right? And then what about this? If I plug in 2 for x and 2 for y, you get 4 over 1, which is 4. Boom. That's the easiest 2 points you're going to get right there. Here's where the points come in. No, not yet. Let f of x be the particular solution to the differential, blah, blah, blah. Write an equation for the tangent line when x is 2, and then use your result to approximate f of 2.1. Okay, how do you write the equation of a tangent line? You need a point and a slope. Now they gave you the point, 2, 3, right? They gave you the point. And then now, how do you find the slope? You use the derivative. What happens when I plug in 2 for x and 3 for y? You get 3 squared over 2 minus 1, which is 9 over 1, which is 9. Come on. So y minus 3 equal 9 times x minus 2. Damn, that's so easy. Now use your result to approximate f of 2.1. So plug in 2.1 into this graph and for x right there. So if I plug in 2.1 for x, what do you get? Y equals, this 3 needs to be moved on the other side. 3 plus 9 times 2.1 minus 2. Now you can leave your answer like that. You don't have to simplify it, but if you feel you need to, 2.1 minus 2 is 0.1 times 9 is 0.9, so 3.9. Do we have the guts to do that? Then just leave your answer like this. That's easy. Now, they didn't ask for under or overestimate, but I'm guessing this year they are. Now, what if you had to say, is this an under or an overestimate? What would that depend on? The concavity of the graph, the function f. So what you would need to do is compute the second derivative. So here's the first derivative. How would you find the second derivative? Well, since there's x's and y's in it, you do implicit differentiation. It's a quotient, so you use the quotient rule. Low d high 2y y prime minus high d low, which is 1, all over denominator squared we go. And then you have to plug in the point 2, 3. But then what do I plug in for y prime, Mr. Park? You plug in this. Well, we actually figured out it's 9 already. Anyway, so if this comes out positive, then that means f was concave up, and then you have an underestimate because the line is below the function. But if this comes out negative, that means the function was concave down, and then you would have an overestimate. But they didn't ask you that this year, but I'm pretty sure they're going to ask you that this year. Part C, here's where the points come in. Solve this differential equation with the initial condition f of 2 is 3. So how do you solve a differential equation like this? You separate the variables. Put all the y's on the left, put all the x's on the right. Like that. You get 1 point just for doing that. Next step, integrate both sides. So we got, now some people are putting natural log of y squared. That's ridiculous. That's a quick way to lose points there. That's the same thing as y to the negative 2. You make the power 1 bigger, put the reciprocal in the front. Plus c. But again, we're going to mush the 2 plus c's together. What is that? Natural log absolute value of x minus 1 plus c. Mush the 2 c's into 1 c. Now you use the initial condition to find the value of c. Now some of you are waiting till the next, later steps to put a plus c. You can't do that because the functions change. Like when you do the same thing to both sides of an equation. As soon as you take the antiderivative, that's where you put the plus c. Now plug in the initial condition. If I plug in 3 for y, what is that? Negative 1/3 is equal to natural log of 2 minus 1, which is 1, plus c. But what is natural log of 1? That's 0. So we just figured out c is negative 1/3. So what do we have now? Negative y to the negative 1 equals natural log of x minus 1 minus 1/3. Mr. Park, what happened to the absolute value? We got rid of it because remember, when you plug in the initial condition, when I plug in 2 for x right there, is 2 minus 1 positive or negative? It's positive, so you leave it alone, you take away the absolute value. However, if you plugged in a number and it came out negative, then you got to negate it. It would be negative x minus 1. You have to decide on which one you're going to use. In this case, the inside was positive, so you leave it alone. Now, all you have to do, so right there, that's everything but one point. The last point is, can you solve for y? First step, multiply both sides by negative 1. So you get negative natural log of x minus 1 plus 1/3. And then the last step, how do I get rid of this? Reciprocatize both sides or raise both sides to the negative 1 power. Negative natural log of x minus 1 plus 1/3 to the negative 1. Boom! Good enough. Okay, number 5. Now this is supposedly the area volume problem, but there's no areas. It's mostly volume. I'm guessing this year they're going to go back to, they're going to give you something where you're actually going to compute the area and then revolve it about something using a disk or washer. Well, the only thing there was in here is the washer, yeah? I mean, not the washer, but the disk. Okay, so you have a funnel thingy like this. Woo! And here's the water. So here's the radius of the water, which is changing, and that's the height, which is also changing. R is 1 over 20, 3 plus h squared, where h is between 0 and 10. Find the average value. Now, they're not even trying to confuse you here. It says find the average value. What did I tell you? Average means average value, but they're not even fooling you. They're saying average value. Some of you are not even doing an integral. Average value is an integral. So how do you find the average value of the radius of the funnel? What's the formula for average value from 0 to 10? Find the average value of the radius. So what is it? That 1 over b minus a, integral from a to b of the radius dh, I guess we're going to do from 0, yeah, so except why don't we just plug it in already? Just take this thing, 1/20th, 3 plus h squared dh. Average means average value. They said average value here. Now, how did you write this down? You get a point. Now, can we compute this? I think we can. So this is 1/10. In fact, shall we bring out the 1/20th also? What is the antiderivative of 3 plus h squared? 3h plus 1/3 h cubed from 0 to 10. Plug in the, so you get 1 point again for the correct antiderivative, you know. So 1 over 200, plug in the top number. 30 plus 1,000 over 3 minus 0 plus 0. And I would just say leave your answer right there. Do not even attempt to simplify anything. Leave it. B. So here, this is how it goes. 1 point for the integral, 1 point for the antiderivative, and 1 point for the answer. Find the volume of the funnel. Well, look at this. How do you find the volume? If you make a rectangle of infinitesimal width and you revolve it around there, you get a disk, right? You know how to do this. So what's the formula for the area of a volume of a disk? Pi times the radius squared. In this case, it's dh, yeah? H is like the y-axis right here. This is h. And, I mean, if you want to think about it like that. Okay? So see how the rectangle is parallel to the x-axis like this? So that means it's going to be a dy one, but the y-axis is like the h here. Okay, so what is the radius of this thing? Well, basically right minus left. So in this problem, h is like the y-axis and r is like the x-axis. Anyway, how do you find that? How do you find the radius of the thing? Well, duh, they gave you the equation right here. 1/20th 3 plus h squared. Pi times the radius squared times dh, which is this infinitesimal thickness. And then you add up all of these disks from 0 to 10, because we're finding the volume of the whole funnel, right? So 0 to 10. Write down that integral, you get 1 point. Now, how do we compute this thing? Now, in order to get the next point, you got to actually come up with the antiderivative. Now, some of you are doing some weird things over here. So first of all, make sure you're doing correct math. When you square something, you have to square everything in that parentheses. So this 1 over 20 gets squared, so that's 1 over 400. And then you got to actually multiply this out, because you can't find the antiderivative. So you got to actually multiply it out. 9 plus 6h squared plus h to the 4th dh. We still haven't got to the point yet, because we didn't find an antiderivative. So let's throw the constant on the side. What's the antiderivative of this? 9h plus, make the power 1 bigger, divide by 3, so that becomes a 2, then 1/5 h to the 5th from 0 to 10. Now you got yourself another point. And then the last one is, can you get the answer? Can you plug in the top number, bottom number, subtract? I hope so. So what do we got? 90 plus 2,000 plus 100,000 over 5, don't even take the chance, or minus 0 plus 0 plus 0. Bam, full credit. Do not even attempt to simplify it. And then part C. The funnel contains liquid that is draining from the bottom at the instant, so this is a related rates problem just by reading that already. At the instant when the height of the liquid is h equal 3, the radius of the surface is decreasing at the rate of 1/5 inch per second. So when I read that, that's telling me r dot is negative 1/5. At this instant, what is the rate of change of the height of the liquid with respect to time? They are asking you to compute h dot. So when you do a related rates problem, first step, write an equation that relates the variables in the problem, which is h and r. They gave you the equation. There it is right there. R equals 1/20th, 3 plus h squared. You don't get a point for that. Second step, take the derivative with respect to time. So r dot, or dr dt, whichever one you want to write. Now 1/20th is a constant, throw it on the side like an unwanted pet. Yeah. And then the derivative of 3 is 0. What's the derivative of h squared, or box squared? 2 box to the first times the derivative of box, which is h dot. So they want you to compute h dot. Now, do they give you all these other things? Yeah. R dot is negative 1/5. Now, a lot of you put positive 1/5. You lost the point on that because it says the radius of the surface of the liquid is decreasing at the rate of 1/5 inch per second. That means its derivative is negative. That negative sign is going to cost you a point there. 1/20th times 2 times h, and they told you at the moment in question, h is 3, h dot. Can you compute what h dot is? I think so. So h dot is equal to negative 1/5. You got to multiply by 20, and then you got to divide by the 2 times 3, which is 6. Leave it. Now, they didn't even ask you for units. Now, usually in a related rates problem, they ask for units, but in this case, they didn't. So don't give it. However, if they did ask for units, what would it be? How is the, remember, h dot is dh dt, height over time. How would you measure a height of something? Well, like in this problem, wouldn't it be inches? And what kind of time interval, time unit do we have here? Second. So the answer would be inches per second if they were to ask for units, but they didn't. So I'm not going to volunteer it if they didn't. Anyway, that's pretty easy to simplify, isn't it? Because 5 goes into 24 times, negative 4/6 is negative 2/3. But like I said, don't risk it, because if you do something wrong, a whole point gets taken off. And finally, number 6. The chart. Okay, k of x is equal to f of, now I'm not going to even read the problem. I'm pretty sure they're going to ask me to take the derivative, and I got to use the chain rule. And now it says, write the equation for the line tangent to the graph when x is 3. So what do you need to write an equation of a tangent line? You need a point, and you need the slope. Now they gave you the x coordinate. How do you find the y coordinate? You plug it in. K of 3 is equal to f of g of 3. So g of 3, look it up on the chart. G of 3 is 6. And then f of 6 is 4. The y-coordinate is 4. 1 point. Now, how do you find the slope? You got to take the derivative. How do I take the derivative of f of g of x? Well, that's the chain rule. F prime of g of x times g prime of x. And then you need to plug in the point, which is 3. So k prime of 3, which is the slope, is f prime of g of 3 times g prime of 3. Now you have to look it up on the chart. What is g of 3? I think we did that before, yeah? It's 6. Just to make sure. G of 3 is 6. What is f prime of 6? Looking it up on the chart. F prime of 6 is 5, so this is 5, times g prime of 3. G prime of 3 on the chart is 2. That's 10. So point slope form now for the final point. Y minus 4 equal 10 times x minus 3. Boom! Okay, I'm recording. Boy, you want to do your thing?
Yeah. Because I'm not going to be able to do it.
Aren't you supposed to be at the assembly?
I don't know, I have a physics exam, so I just came.
All right. Okay. Okay, pardon the interruption.
Sorry. Oh my gosh. So how do I do this?
Okay, you gotta wait till I finish this then. Okay, part B. Come on, this is so easy. Okay, h of x is this quotient here, so compute h prime of 1. So all they want you to do is take the derivative and plug in 1. I think we can do that. So I see a quotient, I'm going to use the quotient rule. Low d high minus high d low all over denominator squared we go. And then you got to plug in 1. Here, I'm just going to do this. Okay, so now you just got to read it off the chart. F of 1, okay, I want to make sure I get this right. F of 1 is negative 6. G prime of 1 is 8. Minus G of 1 is 2. F prime of 1 is 3. All over F of 1 negative 6 squared. Leave it. Do not even attempt to simplify that. Takata. And then C, integral from 1 to 3 of f double prime of 2x dx. Now, a lot of you got 2 points off because you didn't account for the derivative of the box. So, what is the antiderivative of, now if you just had f double prime of x, the antiderivative would just be f prime of x plus c, right? But it's not x, it's 2x. The derivative of the box is 1/2, so you have to adjust for it by putting a 1/2 there. Just like this, what's the integral of cosine of 2x dx? Is the answer just sine 2x plus c? No, you gotta have the 1/2 there, right? It's the same thing. Or if you couldn't do that, then do a u substitution. U equals 2x if you need to. From 1 to 3, factor out the constant. So what does that come out to? Plug in the top number, f prime of 6 minus f prime of 2. And then now we got to read the values off the chart. Okay, what is f prime of 6? 5. F prime of 2, negative 2, which is 7/2. But you know what? Don't even bother. That's it right there. All right. This is your final exam on Friday. Hopefully everybody gets 100%.